We have better maps of the surface of Mars than we do of our own ocean floor.
Let that sink in for a second.
Mars, a planet 140 million miles away. We know more about its craters and valleys than we do about what's sitting right below our feet, under 3 miles of water. And this isn't a funding problem, it isn't a lack of interest. The reason the deepest part of Earth's ocean remains almost completely unexplored is far more terrifying and far more fascinating than most people realize. The ocean covers 71% of our planet. 71%. And yet, as of today, only around 20 to 25% of the seafloor has been mapped with any real detail. The rest? It's essentially a blank canvas. We know more about the side of the moon facing away from us than we do about the bottom of the Pacific Ocean. And the deeper you go, the stranger and more hostile everything becomes, to the point where the physics of the universe itself start working against you. To understand why, you need to start at the surface and travel down. Not just mentally, physically imagine it. You're floating in the Pacific Ocean, somewhere between Japan and Hawaii. The water is warm, turquoise, familiar. You look down and you can see maybe 20, 30 meters before everything turns blue and then black. That darkness below you is not just water, it's a world. A full, layered alien world, with its own mountains, its own valleys, its own ecosystems, and almost none of it has ever been seen by human eyes. You start descending. At 200 meters, the last whisper of sunlight disappears. You are now in permanent darkness. You are now in permanent darkness. No photosynthesis happens here. Anything that survives here has evolved to do so without the one thing that almost every form of life on land depends on:
And you've barely started
going down.
At 1,000
meters, the water temperature has dropped to just a few degrees above freezing. You're in what scientists call the midnight zone.
Creatures down here are
bizarre. Anglerfish dangling their own bioluminescent lures. Viperfish with teeth so large they can't close their mouths.
Transparent animals that look like living glass.
Evolution didn't play by normal rules
whatever worked in the dark.
It played by whatever worked in the dark,
and
the
that
cold,
word, pressure, is the real story.
And that word, pressure, is the real story here.
When you stand at sea
Think
level,
about pressure this way.
When you stand at sea level,
the atmosphere pushes down on you with about 14. 7 pounds of force per square inch. Your body has evolved over millions of years to handle exactly that pressure. You don't feel it because you're built for it. Now imagine going underwater. Every 10 meters you descend, the pressure increases by the equivalent of one full atmosphere. So at 10 meters deep, you're dealing with 2 atmospheres. At 100 meters, 11 atmospheres.
At 1,000 meters,
101 atmospheres.
The pressure at that depth would crush an unprotected human body like a paper cup. But the Mariana Trench, the deepest known point on Earth, sits at nearly 11 kilometers below the surface. That's almost 11 kilometers below the surface. The pressure
almost
reaches
11,000 meters.
1,086
At that depth, the pressure reaches approximately 1,086 times the atmospheric pressure at sea level.
It's like having 50
to put
jumbo
that into an
jets
analogy,
stacked on
you
top
can
of
actually
every
feel
square inch of your
it's like
body,
having 50
not the
jumbo
whole
jets stacked on top of every single square inch of your body, not the whole
every
plane.
part of you,
50 entire planes,
no
per
human
square
body
inch,
survives
every
that,
part of you,
not even
simultaneously.
close. So we send
no
machines,
human body survives
robots,
that, not even close.
Remotely operated vehicles,
so we send machines,
ROVs,
robots,
and autonomous
remotely
underwater
operated vehicles.
And here's
ROVs,
where the engineering nightmare
and autonomous
begins,
underwater
because
vehicles.
building something that can survive
And
at
here's
11
where the engineering
kilometers
nightmare
depth
begins.
is one of the hardest
Because
challenges
building
in
something that can
materials science
survive at
and
11
physics that
kilometers
humans have
depth
ever attempted.
is one of the hardest
Steel, the
challenges
material
in
we use to
materials
build
science
bridges
and
and
physics that
skyscrapers
humans have ever
compresses and
attempted.
deforms under
Steel,
that kind of
the
pressure.
material we use
Titanium
to build
fares
bridges
better,
and
but isn't
skyscrapers,
perfect.
compresses
The pressure
and
at the
deforms
bottom of the
under that kind
Mariana
of pressure.
Trench would squeeze and
Titanium
warp
fares
almost any
better, but
conventional
isn't
container
perfect.
we know how to build.
The pressure at the
Engineers
bottom
have
of the
had to
Mariana
develop
Trench would
specialized pressure
squeeze and
housings,
warp almost
spheres
any
mostly,
conventional container
because a
we know
sphere
how to build.
distributes force evenly
Engineers have
across
had to
the
develop
surface,
specialized
made
pressure
from exotic
housings,
metal alloys
spheres
and
mostly,
ceramics,
because a
machined
sphere
to
distributes
incredibly
force
precise
evenly
tolerances,
across its surface,
where even a
made
microscopic
from exotic
flaw in the
metal
material
alloys
can
and
cause
ceramics,
catastrophic
machined
implosion,
to incredibly
not
precise
explosion,
tolerances,
implosion.
where
The
even a
outside
microscopic
pressure would crush
flaw in the
vessel
material
inward
could
in
cause
milliseconds,
catastrophic
with no
implosion.
warning. And here's something that
explosion.
most people don't think about.
Implosion.
It's not just the hull you
The
have to
outside pressure
protect.
would crush the
Every
vessel
cable,
inward in
every
milliseconds
wire,
with no
every
warning.
joint, every
And here's
viewport,
something that most
every
people don't
sensor
think about.
needs to be pressure rated.
It's not just
the
the
viewport
hull
on
you
a
have to
deep sea
protect.
submersible is
Every
typically
cable,
a cone-shaped
every wire,
piece of
every
acrylic,
joint, every
wider on the
viewport,
outside than
every
the
sensor
inside.
needs to
so
be
the
pressure
pressure
rated.
from the water actually
The
presses
viewport
it
on a
tighter
deep-sea
into its seal
submersible
rather than
is
pushing it
typically
out.
a cone-shaped
The deeper you
piece of
go, the
acrylic,
harder the water pushes
wider
the
on the
window
outside
in,
than
making
the
it more
inside.
secure.
So the
The
pressure from the
engineers had
water
to think about
actually presses
physics
it
at every
tighter into
single
its
step.
seal rather
Then
than
there's the
pushing it
problem
out.
of communication.
The deeper you go,
on land
the
or
harder
even
the
in
water
space,
pushes the window
we
in,
use
making
radio
it more
waves
secure.
to talk to our machines.
The engineers had to think
radio
about
is great
physics
in
at
air.
every single step.
Radio is great in vacuum.
Then there's the
radio
problem
in
of
water,
communication.
useless.
On
Saltwater
land,
absorbs
or even in
radio
space,
waves
we use
almost
radio
instantly.
waves to talk to
Your
our
phone
machines.
signal dies the
Radio
moment
is
it
great
hits
in
the
air.
ocean surface.
Radio is great in
So
vacuum.
how do we talk to an
Radio in
ROV
water?
sitting 11
Useless.
kilometers below a ship?
Saltwater absorbs radio
Sound.
waves almost
We
instantly.
use acoustic modems,
Your phone signal
devices that
dies
send
the moment it
information
hits the
encoded
ocean
in sound
surface.
pulses through the
So
water.
how do we
and
talk to
sound
an
travels
ROV
well in
sitting
water,
11
actually
kilometers
faster
below
than
a
in
ship?
air. around 1,500 meters per second.
We use acoustic
but the
modems,
bandwidth is horrifically
devices
limited.
that send information
Where a modern
encoded
internet
in sound
connection might
pulses
give you
through the
millions
water.
of bits per
And
second,
sound travels
an
well in
acoustic
water,
modem
actually
deep in the
faster
ocean
than in air,
gives you perhaps a few
around
thousand bits per
1,500
second
meters
on
per
a good
second.
day. You can
But the
barely send a
bandwidth is
text message in
horrifically
real
limited.
time, let alone
Where a
stream
modern
HD
internet
video
connection might
or
give
send
you millions
complex
of bits per
real-time
second,
control commands.
an acoustic modem deep
Operating
in
an
the ocean
ROV
gives you
at full
perhaps a
ocean
few
depth
thousand bits per
often
second
means there's a
on a good
significant
day.
delay between
You
when
can
the
barely send a
engineer on
text
the
message in
surface
real
sends a
time,
command
let
and when the
alone
machine
stream
responds.
HD video or
In
send
an
complex
environment where a
real-time
rock
control
fall or a
commands.
sudden current could
Operating an
destroy a machine
ROV
that
at
costs
full
tens
ocean
of
depth
millions of
often
dollars
means
to build.
there's a
That
significant
delay is
delay between
terrifying.
when the engineer
And
on the
then there's
surface
geography
sends a
problem,
command
which
and
most
when the
people
machine
haven't even
responds.
thought about. The ocean
In an
floor is not
environment
flat.
where a rock
It's not
fall or a
smooth
sudden
bowl.
current could
It's one
destroy
of the
a
most
machine that costs
geologically
tens of
complex
millions of dollars
landscapes
to
on
build,
Earth, full
that
of
delay
mountain
is
ranges
terrifying.
longer than the Himalayas,
And then there's the
volcanoes
geography
taller
problem,
than Everest
which most
measured
people
from
haven't even
base to
thought
peak,
about. The
trenches
ocean
that could
floor is
swallow
not
entire
flat.
countries,
It's
and
not a smooth bowl.
hydrothermal vent
It's one of the
fields that
most
look like
geologically
something from a
complex
fantasy
landscapes
novel.
on Earth.
Mapping
Full
all
of
of
mountain
this
ranges
using
longer
sonar
than the
from ships on the
Himalayas,
surface is
volcanoes taller
extraordinarily
than
slow
Everest,
and expensive.
measured from base to
Here's
peak.
how sonar mapping
Trenches
works.
that could swallow entire
A ship on the
countries, and
surface sends a
hydrothermal vent
fan-shaped
fields that
pulse of
look
sound
like something from a
downward.
fantasy
The
novel.
sound hits the seafloor
Mapping all
and
of
bounces
this using
back.
sonar from
Based on
ships
how
on the
long the
surface
return signal
is
takes,
extraordinarily
the ship's
slow and
computers
expensive.
calculate the depth
Here's
at
how
each
sonar
point.
mapping
Then the
works.
ship moves
A
forward
ship on the
and
surface
does it
sends a
again,
fan-shaped
and
pulse
again,
of sound downward,
and again.
and the sound
To
hits the
map a single
seafloor and
strip of
bounces
seafloor
back.
a few kilometers
Based on how
wide,
long the return
the ship
signal
needs to
takes,
sail
the
slowly
ship's
over it.
computers
To map
calculate
the
the
entire
depth at each
ocean
point.
floor at high
Then
resolution
the ship moves
using
forward
current technology,
and does it again,
scientists have
and
estimated
again,
it would take over
and
200
again.
ship years of continuous
To map a
sailing.
single strip of
200
seafloor a
years
few
of a single
kilometers
ship
wide,
doing nothing
the
but
ship
this,
needs to sail
24
slowly
hours a
over
day.
it. To
That's
map the
not a
entire
timeline.
ocean floor
That's
at
a
high
generational
resolution using
project.
current technology,
And the cost.
scientists
A
have
single
estimated it
research
would take
vessel
over
costs
200
tens of
ship years
thousands
of
of dollars
continuous
per day
sailing.
to operate.
200 years
A
of a single
purpose-built
ship doing
deep-sea
nothing but
lander
this,
or ROV
24 hours a day.
capable of reaching full
That's
ocean
not a
depth
timeline.
costs anywhere
That's
from
a
several
generational
million
project.
to over
And the
$50
cost.
million.
A single
to
research
design and
vessel
build.
costs tens of
The limiting
thousands of dollars
factor
per day to
submersible,
operate.
used by
A
explorer Victor
purpose-built deep-sea
Vescovo when he
lander
became
or
the first person to
ROV
reach the bottom
capable
of
of
all
reaching
5
full
oceans
ocean depth
between
costs
2018
anywhere
and
from several million
2019
to over
was
$50
part
million
of a mission
to
that cost
design and
around
build.
$48 million
The limiting
in
factor,
total.
submersible,
That's for one
used
set
by
of
explorer
dives.
Victor Vescovo
Compare
when
that
he
to
became the
space.
first person
The
to reach
James
the
Webb
bottom of
Space
all 5
Telescope
oceans
cost around $10
between
billion.
2018 and
Yes.
2019.
But its findings
It's
are
part of a mission that
broadcast to
cost
the
around
entire
$48
scientific
million
community.
in total.
Deep-sea
That's for one
research
set
has
of dives.
historically been underfunded,
Compare that to space.
scattered across
The
different
James Webb Space
institutions and
Telescope cost
countries,
around $10
and the
billion,
data collected
yes.
is often not shared
But
widely.
its findings are broadcast
There's no equivalent
to the
of
entire
NASA
scientific
for the
community.
deep ocean. No
Deep-sea
unified
research has
global
historically
effort,
been
just
underfunded,
individual research
scattered
groups,
across
universities,
different
and the
institutions
occasional
and countries,
wealthy
and the data
explorer
collected
doing
is
what they
often
can
not
with
shared
limited
widely.
budgets and even
There's
more
no
limited
equivalent of
time.
NASA for
Speaking
the
of
deep
which,
ocean.
let's talk
No
about how
unified
few
global
humans have
effort.
actually been
Just
to the
individual
deepest
research
point on
groups,
Earth.
universities,
The Challenger Deep,
and the occasional
located
wealthy
in the
explorer
southern end of
doing
the
what they
Mariana
can with
Trench in the
limited
Pacific
budgets
Ocean,
and even more
is the
limited time.
deepest known point at
Speaking of which,
approximately
let's talk about how few
10,135
humans have
meters
actually
below
been
sea
to the
level,
deepest
though
point on
measurements
Earth.
have varied
The Challenger.
slightly with improved technology.
Deep,
The first
located
humans
in the
to
southern
reach it
end
were
of the
Don
Mariana
Walsh,
Trench in the
the
Pacific
U.S. Navy
Ocean,
lieutenant,
is the
and Jacques
deepest known
Picard,
point at
a Swiss
approximately
oceanographer who descended in a
10,935
submersible
meters
called
below
the
sea
Trieste
level.
in January
Though measurements
1960.
have varied
That
slightly with
mission took
improved
nearly
technology.
5 hours to reach
The
the
first
bottom.
humans to reach
They
it
spent
were
about
Don
20
Walsh,
minutes there
a
before
U.S.
beginning
Navy
the
lieutenant,
ascent.
and
Then for
Jacques Picard,
decades,
a
almost no
Swiss
one went back.
oceanographer,
The next
who
crew
descended
visit
in a
wasn't until
submersible called the
2012 when
Trieste in
filmmaker
January
James Cameron
1960.
descended alone
That
in
mission
a
took nearly
specially
5
designed
hours to reach the
submersible
bottom.
called the
They
Deep
spent
Sea
about 20
Challenger.
minutes there before
Then came
beginning
Victor
the ascent.
Vescovo in
And for
2019.
decades, almost no
A
one went
handful of
back.
others have followed since.
The next crude
but as of
visit
now,
wasn't until
fewer than 30
2012 when
people in
filmmaker
all of
James
human
Cameron
history
descended
have ever been to
alone
the
in a
deepest
specially
point on
designed
Earth. By
submersible called the
comparison,
Deep
over
Sea
600
Challenger.
people have
Then
been
came
to
Victor
space.
Vescovo in
We have sent
2019.
more humans to orbit,
A handful of others have
250
followed
miles
since,
above Earth,
but
than
as
we
of
have
now, now fewer than 30 people in all of human history have ever been to the deepest point on Earth.
When we do manage
By
to send
comparison,
cameras
over
and
600
sensors
people
into
have been to
those depths,
space.
has
We
repeatedly
have sent more
shattered
humans
our
to orbit,
assumptions about what
250
life
miles
can do.
above Earth,
At the
than we
Challenger
have to the
Deep
deepest
itself,
trench on our own
scientists
planet's
have found
surface.
microorganisms,
And what little we have found
single-celled
when we do
life,
manage to send
surviving in
cameras and
sediment at the
sensors into
very
those
bottom,
depths
thriving
has
in
repeatedly
conditions we
shattered
once
our
considered
assumptions about what
completely
life can do.
incompatible with biology.
At the Challenger Deep
Near
itself,
hydrothermal vents at
scientists have
shallower
found
depths in the deep
microorganisms,
ocean, there are
single-celled
entire
life,
ecosystems,
surviving in
tube
sediment
worms,
at the very
crabs,
bottom,
shrimp,
thriving in
bacteria
conditions
that
we
don't
once
depend on
considered
sunlight at
completely
all.
incompatible
They run
with
on
biology.
chemosynthesis,
Near
using the
hydrothermal
chemical
vents
energy
at
from
shallower depths
hydrogen
in the deep
sulfide
ocean,
venting out of the
there are
Earth's
entire
crust.
ecosystems.
These
Tube
ecosystems
worms,
exist
crabs,
in complete
shrimp,
independence
bacteria
from the sun.
that don't
That
depend on
discovery
sunlight at all.
alone rewrote
They
the
run on
definition of
chemosynthesis,
habitable
using the
environments.
chemical energy from
If life
hydrogen
can
sulfide
thrive without
venting
sunlight,
out of the
without
Earth's
warmth,
crust.
without
These
anything we once
ecosystems
thought
exist
essential,
in complete
where else
independence
in the
from the
universe
sun.
might it exist?
That discovery
The icy
alone
moons of
rewrote the
Jupiter and
definition of
Saturn,
habitable
Europa,
environments.
Enceladus,
If life
are
can
thought to
thrive
have
without
liquid water
sunlight,
oceans
without
beneath their
warmth,
frozen
without
surfaces,
anything we once
warmed
thought
by
essential,
tidal forces,
where else
possibly
in the
venting
universe might it
hydrothermal
exist?
energy, just like Earth's
The icy
deep
moons of
ocean.
Jupiter and Saturn,
Studying the life
Europa,
in our own
Enceladus,
ocean's depths isn't
are
just
thought to have
marine
liquid
biology.
water oceans
It's
beneath their frozen
astrobiology.
surfaces,
It's the search
warmed
for
by
life
tidal
beyond
forces.
Earth.
possibly
right
venting
here, in the
hydrothermal
dark
energy,
water below
just
us,
like Earth's
and yet
deep
barely
ocean.
20%
Studying
left.
the life in our own
There are
ocean's
species
depths
down
isn't
there we
just
haven't
marine
named
biology.
yet, geological
It's
processes
astrobiology.
we don't
It's
understand
the search
yet.
for life
Chemical
beyond Earth,
reactions that
conducted
could hold
right here
keys
in
to
the dark
medicine,
water below
materials
us.
science,
And yet,
energy.
barely
In
20%
2020,
mapped.
researchers
There are
confirmed the
species down
existence
there
of
we
a
haven't
massive
named yet.
underwater mountain
Geological
range in the
processes
Atlantic
we
that was
don't
poorly
understand
mapped,
yet.
despite
Chemical
being known to
reactions that could
exist.
hold keys to medicine,
In 2023,
materials science,
scientists
energy.
on an expedition off the
In
coast of Chile
2020,
discovered
researchers
hundreds of
confirmed
new
the existence
species
of
in
a
an
massive
unexplored
underwater
seamount
mountain range in the
region a
Atlantic
single
that was
trip.
poorly mapped
One
despite
trip.
being known to exist.
Hundreds of species.
In
New
2023,
to science.
scientists on an
Just by
expedition
pointing
off
a
the
camera
coast of
somewhere we
Chile
hadn't really
discovered
looked
hundreds of
before.
new species
That's not
in
the
an unexplored
exception.
seamount
That's the
region
rule.
in a single trip.
Every serious
One
deep
trip.
ocean expedition
Hundreds of
returns with
species.
things that weren't
New
in
to
any
science.
textbook.
Just by
The
pointing a
deep
camera
ocean is the
somewhere we
last
hadn't really
great
looked
frontier
before.
on this planet,
That's not the
and
exception.
the barriers
That's
keeping
the
us
rule.
out of it aren't political.
Every serious
They're not
deep ocean
bureaucratic.
expedition returns
They're
with things
physics,
that weren't in
pure,
any textbook.
brutal,
The deep ocean
uncompromising
is the
physics,
last great frontier
pressure
on
that
this
crushes
planet,
metal,
and the barriers
darkness
keeping
that
us out of
swallows
it
radio
aren't
signals,
political. They're
cold
not
that slows
bureaucratic.
everything
They're
down,
physics.
a geography
Pure,
so
brutal,
vast
uncompromising
that covering
physics.
it would take centuries
Pressure
at
that
the
crushes
pace we're
metal.
moving.
Darkness
And a
that swallows
fundamental
radio
engineering
signals.
problem that has
Cold
no
that
easy
slows
solution,
everything down.
because
A
building
geography
machines
so
that can
vast that
survive
covering it
down
would
there,
take centuries at the
communicate from
pace we're
down
moving.
there, and move with
And a
precision
fundamental
down
engineering
there
problem that has
requires
no
solving
easy
problems
solution.
that sit right
Because
at
of
the
building
edge of what
machines
human
that can
technology
survive
can
down
currently
there,
do.
communicate from
But
down
here's the
there,
thing
and
that
move
stays
with
with
precision down
the
there,
thing that should make you
requires
stare at the
solving
ocean differently
problems that
next time you
sit
see
right
it.
at the edge of
We are
what
not
human
just
technology
ignorant of
can
what's
currently
down
do.
there because we haven't
But
tried
here's
hard
the thing
enough.
that stays with
We
you.
are ignorant
The
because
thing
the
that should
universe
make you
made
stare
it
at the
genuinely,
ocean differently next
extraordinarily
time you see
difficult
it.
to look.
We are
The
not
deep
just
ocean didn't
ignorant
want to
of
be
what's down
explored.
there
It
because
built its
we
own
haven't
defenses
tried
out of the
hard
laws
enough.
of physics.
We are
and
ignorant
only
because
just
the
beginning,
universe made it
barely,
genuinely
tentatively, to push past
extraordinarily
them.
difficult
And the
to
cherry
look.
on top?
The deep
In
ocean didn't want to be
2022,
explored.
researchers found
It built its own
microplastics,
defenses
tiny
out of the
fragments
laws
of
of
human-made
physics.
plastic pollution,
We are only
and
just
sediment
beginning,
samples collected from
barely
the Challenger
tentatively,
Deep, the
to push
deepest
past
point
them.
on Earth, a place where
And the
fewer
cherry on
humans have
top?
stood than on the moon, a place
In
so hostile
2022,
that the engineering
researchers found
required to even reach it
microplastics,
represents
tiny
decades
fragments
of
of
cutting-edge
human-made
science.
plastic pollution,
We got there all
and
right.
sediment
We sent
samples
our
collected
garbage
from the
first,
Challenger
the
Deep,
deepest, most
the deepest
unreachable
point on
corner
Earth.
of the planet.
A place
already
where
has
fewer
our
humans have
fingerprints
stood than on the moon.
We haven't explored
A
it
place
until
so
we've already
hostile that
changed
the
it.
engineering